All right, howdy guys, welcome to Stuart's Corner. All right, this is the classwork that goes with Notes 5. So find an equivalent equation, list the inverse operation or opposite operation that you use to solve. Okay, so in number 1, I know since it's plus 7 that I'm going to have to subtract 7. Okay, and then so I'm going to go ahead and do that now. So I'm going to minus 7, draw my line down the equal side, minus 7 from both sides, plus 7 minus 7, this right here is 0. So you can put a 0 around it or an x, and then we'll bring down the x equals, and then my handy dandy calculator tells me it's negative 11. Actually, I knew it was negative 11 because I have 4 negatives and 7 negatives. And that means I have 11 negatives. So x equals negative 11. Okay, number 2. So again, you have to remember that this is 3 times x. So the inverse of times is divide. So I'm going to divide, and then I'm going to do that right now. Show my work. And divide by 3, both sides, because whatever you do to one side, you do to the other. A negative divided by a positive is a negative. Now on this side, 3 divided by 3 is 1x. Now I can put the 1 there, or I can not put the 1. So I'm going to just leave it as x. Okay, I'll put the 1x. It doesn't matter, either way. And that's my answer. Okay, number 3. All right, so m, and then the 6 on the bottom, this line here, that's the division line, right? With something on the top and something on the bottom. That's what we have. M is on the top. M divided by 6 is what we have. Okay, so the operation is division. And so the inverse will be times. So I'm going to multiply this side by 6. I'm going to multiply the other side by 6. And this 6 over here is over 1. They line up. Okay, so 6 is on the top. So what I end up with is, I'll do some side work here, 6m, because 6 times m. And then the 1 here times the 6 there is 6. But we know 6 divided by 6 is 1, right? Okay. Oh, I got way ahead of me. I didn't even do the problem. Look, I got so excited. I did it wrong. All right, let's erase this stuff. So let's show our work where the work needs to be shown. So again, the inverse operation is times. And here's the work. M divided by 6 equals 12. I'm going to times 6. I'm going to times 6. Right? And almost as if the whole line goes together. So 6m over 6, that's a times, is 1m. And then 12 times 6, 72. I did that in my head. That was hard. Okay, and that's the answer there. All right, now, 4 is very interesting. So if I look at 4, I could either combine my like terms, or I can do 2 inverse operations. It's your choice. So I'm going to do the 2 inverse operations. So the first one I'm going to pick on is this 5. The 5 is negative, so the inverse would be adding. So I'm going to add, and then the next thing, this guy here is 3, and I'm adding it, so I have to subtract it to get rid of it. Okay? So that's what I'm going to do. So I have 3 plus d minus 5 equals 10. Okay, so I'm going to add the 5 first. Okay, so 3 plus d, because negative 5 plus 5, that's a big fat 0. So I get 3 plus d, sorry, equals 10 plus 5 is 15. Now I need to subtract, so now I got to subtract the 3, and that's what I said right there. So subtract the 3, and I'm very bad about not putting my line right now. Oof, I always put a line. Sorry, guys. Okay, 3 minus 3 is a big fat 0. The d comes down. 15 minus 3, or 15 negative 3. I have 15 positives, 3 negatives. So they have to cancel each other out to give me 12. That's what positives and negatives do when you add or subtract them. Cancel each other out. Okay. So there we go. Now, this is like super cool. Number 5. Can't wait. Okay, check if the following is a solution to the equation. So there's 2 ways I can go about this. Right, so how much work do I want to do? Do I actually want to solve this, or do I want to put 3, substitute 3 into the equation? I'll do both, just to see. So this side I'm going to solve, and this one I'm going to use substitution. Okay? Okay, solving, that just means I have x plus 7 equals 4. Okay. X plus 7 equals, sorry, my bad, negative 4. Let me fix that. Negative 4. Yeah, if you haven't noticed, every time I hit the eraser and come back, the font's thicker. You think I would have learned by now. Okay, so I'm adding 7, so I'm going to have to subtract 7. Okay, so minus 7. And that's 0. And I have 4 negatives and 7 negatives, altogether negative 11. So that's the actual solution, and that does not equal negative 3, so no. X does not equal 3. It equals negative 11. Now, substituting means the x, when I go plus 7, comes out, and 3 goes in its place. So no more x. Instead, we put 3 in its place, and then we add 7, and we see if we get negative 4. Well, no, because 3 plus 7 is 10, and that does not equal negative 4. Well, I don't know which one's easier. You'll have to decide. Okay, 6. Well, the solution of negative x equals 1 by negative. I think that was supposed to be b negative or positive. That's the only thing that makes sense. Will it be a negative or will it be a positive? Well, the solution of, well, let's look at this. I have negative 1 times x, some number. Now, is this going to be positive or is it going to be negative? Will the answer be? Will it be a positive or negative? And why will the solution? Okay. I forgot to put the 1 in. I'm going to put that in. Okay, and that'll help out a lot now. Okay, so will negative 1, yeah, you thought I would have known, times x equal 1. Okay, will that equation be a positive answer or a negative answer? Negative solution or a positive solution? Okay, so let's look at this side. It's going to equal a positive 1. And I already have a negative 1. So what does x have to be to give me positive? Well, a negative times what is positive? You're right, negative. And to keep it to be 1, it has to be negative 1, because negative 1 times negative 1 is a positive 1. So the answer is going to be negative. Because the only way to get a positive when you're multiplying by a negative is to have another negative. Does that make sense? I wonder. All right, match the forms. Ooh, how fun. I'm going to love this. Okay, so when you're matching forms, you have to know what the forms are. So you're going to have to write this down. Every time you write it down, you'll remember it more. Y equals mx plus b is slope-intercept. Okay, cool. And then ax plus by equals c, standard. I like standard and general form because they're the same thing except for the seagulls on the other side. And it equals 0 instead. And they always make their coefficients positive just because, I don't know why, but c could be positive or negative. Okay, and then this is general form. All right, so if I have y equals mx plus b, that's super easy. But when x and y are on the same side, because if we look at the equal sign right here, my x and y are on one side and c is on the other. Same with the general form. My x and y is on one side, but 0 is on the other. So y equals mx plus b is pretty easy. It looks like that. That's slope-intercept form, right? Y equals. Okay? And then the next one is 7x minus 2y on the same side equals 3. So that like equals c stuff. That's like standard form. Okay, xy same side on this one too, and it equals 0. Anytime it equals 0, general form. Okay? So going on the other side, if it equals 0, it's general form. Right, now the other two, how can you tell which one's standard form or slope-intercept form? This is like crazy here. So I get a choice. Well, I know this one can't be standard form because x is a fraction. So you can't have any fractions on x and have it be in standard form. That's how I know it's in slope-intercept form, because the slope is actually 1/4 a fraction. And in standard form, you can't have fractions. So then the other one, because it's nice and clean, no fractions, is, the equation. What do you know? Okay, so there's the classwork. Hope you had fun. See ya.